Your inbound flight arrives late. You run through the terminal, reach the next gate, and board with seconds to spare. Your suitcase had the same itinerary, but it did not have the same route, and it did not get to skip a single required step. The passenger moves through signs, corridors, and a boarding pass. The bag moves through unloading crews, vehicles, conveyors, scanners, databases, sorters, makeup areas, and another loading team. A connection is therefore not one race. It is two systems trying to meet the same departure. So what happens when those systems separate? The suitcase does not simply become lost. It changes status. The normal journey ends, an exception journey begins, and the airport must prove where the bag was before it can decide where the bag goes next. The journey begins when a physical suitcase receives a digital identity. The tag links the bag to an itinerary and carries a standardized license plate number. From this point forward, the system is not only moving luggage, it is maintaining a relationship between an object and a record. The printed tag is the visible part. Behind it sits routing information that tells handling systems which flights and destinations belong to the bag. The label can be scratched or folded. The data can be incomplete or late. Reliability begins by keeping both representations connected. At induction, a scanner attempts to identify the bag before a conveyor commits it to a route. A successful read lets software connect the moving object to the planned journey. A failed read creates uncertainty, and uncertainty usually sends the bag toward another decision point. In the United States, checked baggage screening can involve automated explosives detection, image review for alarms, and manual inspection when an alarm cannot be resolved. Security is not a decorative checkpoint. It is a required branch that can return the bag to flow or hold it for resolution. Not every suitcase fits the automated path. Oversized items, unreadable tags, unresolved screening alarms, and other exceptions can leave the main flow. The system remains reliable only if these branches preserve identity and return cleared bags to the correct journey. IATA Resolution 753 defines 4 core tracking points: acceptance from the passenger, loading onto an aircraft, transfer, delivery, or acquisition, and final return to the passenger. These events do not show every meter traveled. They create an audit trail across the moments where responsibility changes. The suitcase is physical, but the promise is informational. This identity should be at this place before this deadline. The machinery can move thousands of objects. The harder task is making sure each object keeps the correct promise while the airport changes around it. Beyond the check-in hall, separate input belts merge into the baggage handling system. What looked like one conveyor becomes a network of junctions, inclines, scanners, screening machines, storage positions, and staff work areas hidden behind walls and below passenger floors. Sortation converts itinerary data into physical direction. At each controlled branch, the system needs enough confidence to send the bag onward. A fast belt is useful, but speed without a correct destination only moves an error farther through the airport. At a major hub, this happens at industrial scale. Heathrow says its systems scan and sort up to 140,000 departing bags in a day. That number is not a template for every airport. It demonstrates why baggage handling is infrastructure rather than a longer version of the carousel. Bags do not all arrive at the loading area together. Some enter early and need to wait. Others arrive near the working deadline. The system must absorb these different rhythms, then assemble the correct set for one flight without mixing it with the departures beside it. Before loading, baggage reconciliation connects the planned passenger journey, the bag identity, and the aircraft assignment. This does not mean every airport uses identical hardware. It means the final physical handoff needs a trustworthy answer to a simple question: does this bag belong on this departure? Automation ends at physical edges. Ground handlers still move, position, and stack bags, especially inside aircraft holds. Mechanical loaders reduce parts of that effort, but the final arrangement remains a human and equipment task performed inside a turnaround that is already counting down. The loading event creates another confirmed point in the record. The bag is no longer merely somewhere inside the airport. It has been assigned to a physical aircraft. For a connecting itinerary, that confirmation also tells the next airport what should soon arrive. The first flight leaves with the passenger and bag together. For a direct trip, the next major handoff may be arrival delivery. For a connection, the aircraft is carrying both into a second deadline that began before the wheels ever touched the ground. At the hub, the passenger sees an arrival gate. The bag reaches an aircraft hold that must be opened, unloaded, and divided by destination. The transfer clock is already running, but the suitcase cannot read signs or choose a shorter corridor. Local bags and transfer bags need different outcomes. One group moves toward passenger reclaim. The other must re-enter a departure process. Separating them correctly is the first transfer decision, because a bag sent to the wrong branch can lose time even while remaining inside the same airport. Resolution 753 includes transfer delivery or acquisition because a connection can cross operational boundaries. The next airline, airport system, or handling team needs evidence that the bag reached the agreed transfer point. Physical custody and digital visibility must change together. The identity remains the same, but the active instruction changes. Transfer messages and shared baggage data allow the next handling process to understand the onward flight. The bag is not following a painted line. It is repeatedly receiving a new physical destination from its record. At some hubs, the next aircraft may be nearby. At others, the route crosses terminals, tunnels, transfer facilities, or apron roads. A short passenger connection can still contain a long baggage journey because the two networks are designed around different access, security, and handling constraints. Connection time is not one open block. Unloading consumes part of it. Identification and transfer consume more. Sortation, reconciliation, transport to the aircraft, and loading each need their own window. The useful margin is what remains after every required step takes its share. Tracking data can help operators identify hot connections, bags with little time remaining. Priority can move one suitcase ahead of routine flow, but it cannot erase distance, reopen a closed load, or create unlimited staff and vehicles. Priority changes sequence, not physics. Even bags headed to the same aircraft can have different deadlines. One may have waited inside the airport. Another may be arriving from a delayed flight. The destination is shared, but urgency belongs to the individual journey. That makes transfer baggage a live scheduling problem. The real constraint is not simply conveyor speed. It is remaining time multiplied by unfinished work. A bag can be physically close to the aircraft and still be operationally far away if its identity, screening status, custody, or loading instruction is unresolved. Now delay the inbound flight. Nothing dramatic has to break. Whether congestion, a late gate, or another operational constraint can remove the margin before baggage crews touch the hold. The suitcase arrives inside a system whose original plan may already be impossible. The passenger can be told to run directly to a gate. The suitcase cannot make the same shortcut. It still needs a physical unload, a correct identity, a transfer route, a loading position, and a confirmed handoff. This is how the passenger can make a flight that the bag misses. At some point, the outbound process stops accepting normal additions. The exact rule varies, but the principle is consistent. Loading must finish in time for the aircraft to close and depart safely. Once that window disappears, speed alone cannot restore the original journey. The bag now becomes an exception. That does not mean the system knows nothing. It may know the last confirmed scan, the intended flight, the current custodian, and the location where normal routing stopped. Recovery begins by converting those fragments into a new executable plan. A missed connection creates pressure to move quickly, but the next movement still has to be correct. Reconciliation and tracking help prevent an outdated instruction from sending the bag into another wrong handoff. The system must stop trusting the old plan before it can build a new one. In most cases, a mishandled bag is assigned to another flight and reinserted into the normal departure process. But another flight is not merely a matching city name. The operating carrier, available route, handling agreements, timing, and destination recovery capability all matter. If the original carrier keeps custody, the initial passenger acceptance still applies. The bag receives a new flight assignment, and its loading onto that new aircraft must be recorded. The exception journey reuses the original identity while replacing the segment that failed. If another carrier will transport the bag, the recovery path adds a custody exchange. The physical handoff or delivery to an agreed transfer point should be recorded. A new route therefore creates not only movement, but another organization that must recognize and continue the same promise. The outbound aircraft leaves. From the passenger seat, the outcome is already visible only as uncertainty. Inside the airport, the bag is no longer racing that departure. It is waiting for a route that can still be completed and proven. Recovery starts with the audit trail. Acceptance confirms the bag entered the journey. Loading confirms the first aircraft. Transfer tracking confirms whether it reached the hub process. The last reliable event narrows the search and tells operators which part of the network should act next. Tracking does not create a live camera on every suitcase. It creates verified anchors. The space between two anchors can still contain uncertainty, but it is smaller than an airport. Better event quality shortens the distance between "we do not know" and a useful operational search. Standard baggage systems include reflight messaging, so a changed assignment can move through the operational network. The physical suitcase may remain still, while its future route changes in several databases. Only after the new instruction reaches the right handlers can movement resume. Once the route is ready, the bag is reinserted into the normal departure process. It must again be identified, sorted, delivered to the new flight, and recorded at loading. Recovery succeeds by making an abnormal journey compatible with the same controls used for an ordinary bag. The new loading event is more than good news. It proves the recovery plan reached an aircraft. Until that moment, the bag may have an itinerary without transport. The second journey becomes real only when information and physical custody meet again at the aircraft. The passenger and suitcase now arrive on different schedules. At the destination, the bag cannot simply be placed on a carousel hours later and left to chance. Its delayed status changes the final handoff and the work required to complete the original promise. A mishandled bag may be returned at a home or hotel instead of an arrival belt. Resolution 753 guidance treats that delivery as a tracking event too. The journey ends only when custody returns to the passenger, even if the airport portion finished much earlier. A delayed bag with a confirmed identity and a new route is an operational problem. A bag with no trustworthy location or broken identity is a search problem. Passengers experience both as absence, but the system needs very different information to resolve them. This vulnerability appears across the industry. In CETA's 2025 dataset, transfers remain the largest driver of baggage mishandling at 39% of cases. The figure is an industry estimate, but the mechanism is clear. Every connection adds deadlines, custody changes, and another opportunity for data and movement to separate. One missed bag is manageable. A wave of late inbound flights creates many urgent bags at once. The same exception desks, vehicles, scanners, sorters, and handlers now face concentrated demand. A delay that began in the flight network becomes a baggage capacity problem on the ground. Recovery does not operate in an empty airport. Reflight bags share infrastructure with normal departures and other hot connections. Giving one bag priority may consume capacity elsewhere. The system is continuously deciding which work can still meet a useful deadline. A conveyor moves the bag, but data determines whether the next team knows what happened. Missing, late, or unshared events widen the search. Accurate tracking does not prevent every missed connection. It makes the failure visible earlier and gives recovery a smaller problem to solve. No single organization controls the entire journey. Airports may operate core systems. Airlines own the passenger promise and routing decisions. Ground handlers perform many physical transfers. Reliability emerges only when these parties exchange usable information at the same moment's custody changes. Physical resilience provides alternate belts, routes, work areas, and procedures around a failure. But an alternate path helps only if the bag can be identified, directed, staffed, and delivered before the remaining window closes. Redundancy is operational, not merely architectural. Security rules, terminal layouts, carrier agreements, aircraft loading methods, and local procedures vary. A small airport may rely on direct manual movement. A hub may use kilometers of automated handling. The shared principle is not one machine. It is preserving identity through every required handoff. Run the journey again. The passenger hands over a suitcase. A tag gives it an identity. Screening clears it. Sortation converts the itinerary into a physical route. Reconciliation and loading connect it to the first aircraft. Every step keeps object, record, and deadline aligned. At the hub, the route's separate. The passenger crosses the terminal. The suitcase passes through unloading, transfer tracking, new sortation, and another load. When both reach the outbound flight in time, the complexity disappears behind an ordinary arrival carousel. When the bag misses, the system preserves what it can: identity, last location, custody, and destination. It replaces the failed segment, records the new load, and creates a final delivery outside the original schedule. Recovery is a second journey built from the evidence left by the first. That is the answer to the opening puzzle. A passenger can make the connection while a bag misses it because they do not travel through the same system. The bag succeeds only when its location, identity, custody, and remaining time continue to describe the same journey. The next time a suitcase appears on a carousel, the visible achievement is simple: one object reached one place. The hidden achievement is that dozens of machines, messages, and people agreed about which object, which place, and which moment all the way there.